University, Japan.
Good morning. My name is Mikio Fukuhara, and today talk about Earth factories, nuclear transformation, and the creation of elements. My coworker Alexander Yoshino and Professor Nobuyuki Fujima. Before going to the convention theory, I'd like to talk about conventional theory of elementary synthesis. According to nucleosynthesis theory, the universe began 13.8 billion years ago with Big Bang. Hydrogen and helium and lithium were formed, and after that, element lighter than ion were formed by CNO cycle transmutation by firsters. After that, supernova explosion created the element behavior than ion via neutron incorporation of using these stars. As a result, many elements disperse the universe, and our Earth was formed by accretion of solid materials with all elements together with terrestrial planets such as Mars and Jupiter and Moon also. On the other hand, Fukuhara proposed a new model for the formation of nitrogen, oxygen, and water from an enzymatic nuclear transformation of carbon and oxygen nuclei found in the aragonite CaCO3 lattice of Earth's mantle or crust, which is enhanced by the attraction caused by high temperature and high pressure in the Earth's interior. This figure shows the configuration of aragonite in 111 planes. I doubt of element concentration in the terrestrial planets. So I first compare the element concentration for Earth, Mercury, Venus, and Mars. This figure, as a left figure, shows the atomic number and dependence of concentration of elements. The element increase abruptly increase to silicon and decrease like this with increasing of atomic number regardless of other planets. Left figure shows the atomic number dependence of weight difference. In upper figure, the positive values represented an absolute increase in these elements in Venus and Mars compared with Earth. On the other hand, in lower figure, negative values indicates a higher ratio on Earth compared to the Venus and Mars. You can see the carbon and nitrogen, phosphor and sulfur and chromium, manganese and iron larger than that them of Mars and Venus may have been produced in the Earth's interior after the formation of terrestrial planets around 4.6 billion years ago. Since atmosphere is continuously depressed into space, and our atmosphere could not keep the pressure need to the us our life on the Earth. So we first consider the formation of lighter elements in Earth's inside. Thermal energy delta Q for two-body nuclear reaction can be carried through the rest mass delta M of the reactants M1A and M2B and products M3C and M4D. Since nuclear reaction favor light nuclei with smaller radii, we use some light isotopes with a lower abundance ratio to calculate reaction energy delta Q using this 31 reactant element data. We calculate about 150,000 equations and sorry. And this figured out local value. And this shows this figure shows the lowest energy from lithium to iron. And this figure shows the second lower energy from lithium and iron. Next, we summarize formation energy with first lowest and second lowest energy. You can see they are considerably small under minus 100 kilo electron voltage. For example, formation energy of magnesium is around 10,000 times larger than that of alumina at room temperature and one atom. But these reactions are non-equilibrium, so they don't obey the rule of parity and momentum balance. There is a possibility for element creation in Earth's interior, provided that suitable temperature and pressure applied to natural minerals with reactant elements in natural compounds of the Earth's interior. So we choose 3 natural elements really presentably. This graph shows the transmutation reaction of silicon and titanium. We choose magnesium ion SiO3 and enstatite ferroceriate solution structure of high pressure phase. I first confinement due to high pressure. The magnesium and ion distance day1 at 1030 gigapascal and 3200 Kelvin, corresponding to 2600 kilometers below the Earth's surface, can be estimated as 0.191 nanometer. And this reduced distance D1 is larger than distance required for dynamical nuclear reaction of 0.094 nanometer. So very larger. So next we consider confinement due to high temperature. According to Arrhenius equation, K1, K0 equals 10.74, and using this value, potential of the repulsive interaction between atoms can be calculated using this formula, and reduce distance of D2 is 0.1563 nanometer. The value is larger than 0.094 nanometer still. So we calculate and consider an effective physical catalyst on dynamical reaction between magnesium and iron by symmetrical meson theory of nuclear force. We use this formula and obtain the reduced distance. D3 is 0.0808 nanometer. This value is smaller than 0.094 meter. So this value would be lead to the nuclear reaction between magnesium and iron nuclei. Next, I consider transmutation reaction of sodium and silicon. We choose bridgebonite, MgAl2O4 under high pressure of 60 gigapascal based on data obtained by quantum mechanical solution calculation. So first, consider the confinement due to high pressure. When the bridgebonite is compressed at a high pressure of 60 gigapascal, which corresponding to the pressure condition of the lower mantle, upper mantle boundaries. That distance D1 is 0.335 nanometer. It's very considerably larger than 0.094 nanometer. So next, consider confinement due to high pressure. The bridgebonite exists at 3,221 kilometer and 117 gigapascal, corresponding to a depth of 2,600 kilometer in the lower mantle region. So obtained reduced distance D2 is 0.1563 nanometer. The value is larger than 0.094 nanometer still. So lastly, we consider effective physical catalyst between magnesium and aluminum. The reduced distance D3 is 0.0780 nanometer. That value is smaller than 0.094 nanometer. This value would lead to the nuclear reaction between magnesium aluminum nuclei. Lastly, we consider transmutation reaction of oxygen and carium. We choose carbonite L2SiO5 which exists at high pressure from a temperature exceeding 2,300 Kelvin and pressure about 14 Pascal as a reactant material. And first, we consider confinement due to high pressure. The carbonite is compressed at a high temperature of 23 gigapascal, which corresponds to the pressure condition of the lower upper mantle boundary. The reduced distance D1 is 0.277 nanometer. This value is considerably larger than 0.094 nanometer. So next, we consider confinement due to high pressure. The carbonate 3 phase exists at 3,200 Kelvin and 117 Pascal, corresponding to depths of 2,600 kilometers in the lower mantle region. The calculated reduced D2 distance D2 is 0.1520 nanometer. This value is larger than 0.0 94 nanometer stereo. So lastly, we consider effective physical catalysis between aluminum and silicon, and obtain the reduce this and D3 is 0.0786 nanometer. This part is smaller than 0.004 nanometer. So as a result, lighter oxygen and kalium were formed from kinase 3 L2SiO5. Lastly, I considered geographical condition for generation of lighter elements. So this figure is a cross section of Earth. The generation of large amount of lighter elements appear to be linked to the plate tectonics after the nucleation of liquid core. The existence of lower mantle and high temperature over 3,300 Kelvin and pressure over 117 gigapascal at a depth of 2,600 kilometer depth could have played a crucial role in the general generation of lighter elements. In this figure, lithosphere subduction caused by plate tectonics would deliver higher quantities of fresh MgFe SiO3 perovskite, MgL2O4, and aluminum silicate L2Si5 minerals due to the lower mantle. On the other hand, nitrogen and helium gases are discharged by volcanic and hydrothermal activities in the atmosphere and are realized from the Earth's atmosphere into our space. In addition, asteroid condition and events strongly affect related on the negative elements also their important role in optic continental growth, the intrusion of granitic magma, and shifting the mantle convection patterns. In here, and regarding the physical catalysis attraction mechanism responsible for accelerating the confinement of two nuclei in natural compound lattices, excited electron and neutron are thought to have been generated by stick sliding during supercontinent evolution, shifting of the mantle's convection pattern triggered by major asteroid collisions and nuclear fusion in the Earth's core. This figure is a change in the concentration of atmospheric carbon dioxide, nitrogen, oxygen from billion years ago to the present time. Conclusion. Our study processes of a potential model for the creation of a light element nuclei up to ion with an atomic number of 26 in Earth's interior. First, proposed process would result from the thermonuclear transmutation of the consistent element of natural mineral compounds such as prismonite, kyanite, confined by high temperature 3,200 Kelvin and pressure 117 gigapascal in the lower mantle, corresponding to the depths of 2,600 kilometers due to mantle convection dynamics driven by plate tectonics. Second, this study will have a great impact on the geophysical field, and the result will indicate the possible research direction for the potential for the creation of elements required by man in future space development. Thank you for your attention.